Okay. Okay, today we will discuss about solar power generation options. We already discussed in last videos. Only one alternate to fulfill the electricity needs of the world. Only one source is solar. So, how many methods we can generate the solar electrical energy, solar power generation methods? The first one, solar photovoltaic, all are knows. Next, solar thermal. In solar thermal, two options are there. One is solar rated, second one is solar alone. Solar rated means existed thermal power plants. It may be steam boiler based thermal power plants, or it may be combined cycle thermal power plants. Their substitute of the feed water heaters we can do. That is one option, solar rated. Coming to the solar alone means Rankine cycle or Stirling engine cycle systems, parabolic trough. The beam radiation, absorption of the beam radiation, we can convert into the heat. That is maybe parabolic trough systems, linear Fresnel lens or parabolic trough is a uh, line contact, line focus. And next, parabolic dish and central power tower, point focused dual axis stacking based concentrators. By using this one, we can harvest the solar radiation and it is converted to heat. Again, heat, same thermal power plant will run. Once heat is available in boiler, means we can generate steam, it expansion turbine, and the electrical energy production, rotation of the shaft will come into the picture. These are the feasible methods for generation of the electricity by using solar energy. Different harvesting methods indirectly for generation of the electricity. First of all, before starting that one, in the what are the in solar radiation? All are not the parts of solar radiation. 5% ultraviolet radiation is there. Total solar constant I already mentioned 1300 53 watt per meter square of the solar radiation is coming from the sun to the earth. Out of that, 5% is ultraviolet radiation, 43% is visible radiation, 52% near infrared radiation. Suppose solar PV panel, photovoltaic panel means indirectly semiconductor. Semiconductor can capable to convert only visible radiation, not ultraviolet or infrared radiation. So solar panel, the input energy itself 43% only. Out of 1353 watt per meter square, only 43% of energy, only the input. Remaining solar radiation, indirectly it is reducing the efficiency of the semiconductor. Indirectly. So this point we want to concentrate. Any person claiming my PV panel efficiency 90%, 80% means it is a flaw. Input itself 43 means how you will get the 90%? The first question mark. But easy construction because semiconductor plates, the cost of the semiconductors per watt cost drastically reduced from 2007 to 2021. I think in 2007 to 9, 160 rupees per watt monocrystal. Polycrystal means maybe 120 to 130. At present, polycrystal is 15 rupees, monocrystal is 30 rupees per watt cost. Means drastically cost is reduced. Second, there is no maintenance once you install. Wherever free terrace is available, free land is available, you can install the system. Only structural support cost, only extra cost. Investment cost is drastically reduced, only 3 to 5 crores only. The unit cost, I think now in Rajasthan they installed latest plant. The tariff cost only 2 rupees 40 paise. 2 to 4 rupees maximum. So because of that, majority of the in India you can see solar power plant means only solar photovoltaic only. Even though the utilization of the percentage of radiation is only 43 percentage. Out of 43, it will convert. Overall efficiency of panels may be 15 percentage, 16%, 17%. That's all. Next, other options we'll see because all harvesting options. Next, solar concentrated systems, solar thermal power plants. Here, suppose first concentrator is a line contact concentrator, parabolic trough. You can see this is the parabolic trough. One trough, one collector, wherever we are calling one collector means it contains 12 modules like this 1, 2, 3, 4, 12 modules called one collector. One module length is 12 meters, width is 5.7 meters. You can estimate 1.144 meters length, 5.7 width is called one parabolic trough collector. Like that, number of collectors we are connecting according to our need. At the focal point receiver is there, evacuated tube receiver. Here heat transfer fluid is circulating. So entire field heat transfer fluid has to rotate, absorb the heat and transfer to the heat to the boiler. So more pumping losses are high, and single axis tracking cosine losses also is there. So first method. Move to the second method. Central tower receiver, we can eliminate the pumping losses. Why? Because in the central tower itself, boiler you can place, automatically you can run the thermal power plant. But one drawback, we already knows the solar constant of 1353 watt per meter square beam radiation is not reaching to the earth due to the pollution. Absorption or diffusion of the radiation will take place. Maybe 700 800 beam radiation only is the reaching to the reflector. Again, this reflector, heliostat reflectors we are calling, one heliostat dimension is 10 meter by 10 meter. It is reflecting again to the receiver, focal point receiver. So again, diffusion of the beam radiation will take place. So solar input is reducing drastically. Heliostat system, especially in India. Not only India, any pollution country. The pollution content is day by day is increasing. So diffusion of the radiation, beam radiation will take place. This is heliostat system means central tower system means it's a big parabolic dish. We splitted the reflector. That's all, nothing else. In top view you can see it's a big parabolic dish. That's all. Third option is a parabolic dish concentrated system, small capacity. At present, IOCL is working on to develop 5 kilowatt base system. In the focal point, dual axis tracking, in the focal point, they are placing Stirling engine, not Rankine cycle thermal power plant. They place Stirling engine. They are interested to develop that 5 kilowatt parabolic dish decentralized systems, because for agriculture purpose their main target is agriculture purpose. So these are the three solar concentrated thermal power plants options are there. Then what is the unit cost, estimation unit cost? You can see installation cost of parabolic trough system 21 to 28 crores. Solar PV panel only 2 to 4 crores, and central tower 24 to 29 crores. Parabolic dish cost, because this is a decentralized system, 14 to 16 crores investment cost. Next, unit cost, you can see the efficiencies are high, the design efficiencies are high, not 15%, 24%, 27, 30% also there. Why? Because entire solar radiation, visible radiation, infrared radiation, ultraviolet radiation, all radiations we are using for generation of the power, no doubt. But the investment cost, installation cost and unit cost is high. The unit cost is 12 to 15 rupees for parabolic trough system. Central tower system 10 to 12 rupees. Parabolic dish system 9 to 11. This is the estimation cost. Myself I calculated based on the National Renewable Energy Laboratories data. The cost of different components I took from that website only, and I published the data also in a very good research publication. So that is the main reason. You see the MNR website now. In MNR website, the capacity increased 2.6 gigawatt to 42 gigawatt. What capacity? Solar capacity, not solar thermal power generation capacity. Solar PV. Even though solar PV panel is not utilizing entire solar radiation, 45 to 50% only it is can convert the visible to the electrical energy. but the installation capacity drastically increased. Why? Because cost, operation and maintenance. Two things are driving the technology. Your technology efficiency is high, okay, no problem. But your investment cost is high, or your operation maintenance cost is high. Why? Because concentrated system means separate engineering is required, separate tracking is required. Per unit operation and maintenance costs are increasing drastically. For solar PV, there is no operation maintenance, only cleaning of the panels only required. That's all. And you see the tariff also. This is directly I took from MNR website only. You can see in a MNR website. The tariff also reduced 2.44 in Rajasthan. Latest they installed solar PV plant. Only unit generation cost is 2.44 rupees. So solar thermal efficiency is high, but investment cost and operation maintenance cost is high. Efficiency high, this two also. Solar PV efficiency is low. Why? Because the semiconductor unable to utilize the infrared rays or ultraviolet rays. Only it can convert visible radiation. That's why efficiency low. But there is investment cost is reduced drastically, and operation maintenance cost almost eliminated. General operation maintenance cost is more than sufficient. So these are the brief idea about solar power generation technologies. I think with this I am ending the session. Thank you. Thank you.